to go.
Okay. So can everyone see my screen? Can everyone see my screen?
Yes, yes, we can.
So we'll be doing searching and sorting. So as the name suggests, given an array, we have to search in the array. Given an array, we need to sort the array. We'll be going through different techniques in that to give you a fair intuition about all the ideas. What is the main agenda of today's session? The main agenda of today's session is to get an intuition of all the algorithms. Means you get an intuition, a fair idea on how different sorting and searching algos work. Also, emphasis on the idea behind each algos. Obviously, in the computer programming world, they won't ask you, they won't simply ask you to do merge sort. There'll be a problem inspired from the idea behind merge sort or quick sort or whichever sorting algorithm, right? So it's a very chill session. I want all of you to relax and just grasp the idea, and that'll be more than enough, and you'll be very good to go. So we'll start off with the simple linear search. You guys would have already surely learned this back in your first years itself, but we gotta start somewhere, right? So we'll start with linear search. The thing with linear search is, what is the main idea behind linear search? You start from the leftmost element of an array. You start from the leftmost element of an array, and you one by one compare the particular searching element with each element of the array. Okay, and if the searching element matches with an element, then return the index. If it doesn't, just return -1. To give you an example, let's say you have an array which is 5, 10, 2, 4, 8, and 23. Let's say this is your array, and you want to search for the number 2. Okay, your searching element is 2. So you start from the leftmost index of the array. So you start from 5. We check if 2 is equal to 5. So 2 is not equal to 5, right? 2 is not equal to 5. So you move on. Is 2 equal to 10? No, 2 is not equal to 10. You move on. Is 2 equal to 2? Yes, 2 equal to 2. And what is the index of this? The index of this, surprisingly, also happens to be 2. Right? So you basically go one by one, compare with every element, and then you do it. Right? Can anyone tell me a better, the time complexity of this is O of n. The time complexity is obviously it's O of n. Can someone please tell me a better way, can someone tell me a modified version of this? Modified version of this, any ideas? If someone could tell me, how can I optimize this to make the linear search better? Any answers? Okay, I'll give you a hint. Over here, we are starting from the leftmost element. Why can't I start from the rightmost element? Can I start from the rightmost element? Can I do that or not? Hello, people. I'm asking you. Can I start from the rightmost element also, right? Why start only from the leftmost element? So the idea here being, let me do it from both sides. In the same for loop, let me attack from both sides. Let me attack from the left side and from the right side. What is the advantage of this? Let's say, by chance, the element you wanted to search was 23. Okay, if you're doing the left-wise approach, no, you would have gone for around 1, 2, 3, 4, 5. You would have gone for at least 5 iterations. Only after the 5th iteration would you have returned that the index of this is the last. But had I started from the right, then in the first iteration itself you would have got the answer, right? So that is the modified linear search. So I will share the code with you. 1 second. Did everyone understand the modified linear version? Why specifically? We would check 2 times at first, and yeah, we will be checking 2 conditions. Yeah, we'll iterate from the left side. We'll iterate from the same iteration. We'll check from the right and left, and we'll do it. Let me first show the normal linear search. Let me just I already have the code typed for you guys. I mean, the main reason for this is so that I could finish a lot more algorithms in the same class. Instead of me typing out the code, I already have the code typed out for you before. I'll to present my screen. So this is the normal linear search. So I iterate throughout the entire loop. If that particular element equal to the searching element, the searching element here is x. If ARR of I equal to x, you return I. If not, then you return -1. After you've completed the loop, obviously you haven't returned something, so you return -1. Okay, this is very simple, which all of us will have read in our first sem. So yeah, it is the element that we wanted to search was 2. X is the element that we want to search. The element that we wanted to search was 2, and it's found at the index 2 and location 3. Location is index plus 1, right? So index starts from 0, 0, 1, 2. So obviously you get it. So basic linear search, O of n, no problems. Now let me do the the modified linear search. 1 second. So this is the modified linear search. Nothing fancy, nothing fancy. Even though you may see vector and all, you can also do it simply with an array. Nothing that fancy. The thing is, I told you, right, I'm attacking it from the left and right. Okay, just concentrate on this part of the code. Left equal to 0 and right equal to the size of this thing, right? The length is the size, and the right index will be pointing at the last this thing. If ARR of left equal to search element, the position that I want to search is left, and then I break out. I have found me I need to break out, right? I need to break off from the loop. I don't have to do more iterations. If at the same time I'm checking one more condition, if ARR of right equal to search element, then you again break. Left plus plus, right minus minus. Did everyone understand this? This is the same thing, just these two extra lines. Left plus plus, right minus minus. Did everyone understand this? From the left side also I'm attacking, from the right side also I'm attacking. Same O of n, I'm just checking two conditions. Did everyone understand this? I'm pretty sure you wouldn't have learned this in your first sem, this attacking from both sides. Is the idea clear? Okay guys, thank you. So I'll run this thing. So over here, the element that I want to search was 23. I run it the formal way, I would have had to do 1, 2, 3, 4, 5 iterations. One year I would have gone to 23. But when I'm doing like this, in the first iteration itself, I'm getting 23. So even though the time complexity is the same, it's more of an optimized approach. So this was pretty simple. I'll go on to the next concept, which is binary search. So we have an entire session based on binary search. We have an entire session dedicated towards binary search. So I won't be spending much time in that, but I'll surely explain the basics of binary search. So what is one of the biggest prerequisites of binary search? What is one of the biggest prerequisites of binary search, if someone could tell me?
Should be sorted.
Exactly. The thing is binary search is the entire array should be sorted. Once you're done, once it's sorted, you can easily do. So I'll first tell an example and then we'll work it out. Let's say the array is 2, 3, 10, and 2, 3, 4, 10, and 40. This is your array. The element that I want to search is 10 over here. How do I go about it? So what happens in this binary search is, you basically search for the middle element. You search for the middle element. Once you have the middle element, what is the middle element here? The middle element is 4. The middle element is 4. Is 10 greater than 4 or less than 4? The searching element is 10, right? You know that 10 is greater than 4. So I don't need to concentrate on this part of the array. This part of the array, I don't need to concentrate on. I will just concentrate on this part of the array. Okay. Again, here, what is the middle, this thing? The middle over here is 10 over here. The middle here is 10. It's integer, right? So at 1, 0, 1, 2, 3, 4. 3 plus 4 by 2. So 3 plus 4 by 2 gives you 3 again. 3 plus 4 is 7. 7 by 2 is 3.5. But if you do it in integer, int of 3.5 is nothing but 3, right? So this is the middle element again over here. So it's 10 equal to 10, yes, and then you return it out. This also, I'm pretty sure all of you would have learned it in your first sem, so I'm not going in depth. So should I go with one more example, or shall I jump into the main sorting algorithms? You have a dedicated session. The next session is basically a dedicated session of this binary search, where one of the seniors will be explaining the in-depth thing of binary search. Did everyone, should I proceed, or do you want me to elaborate more on this? Hello? Please reply.
I can proceed, bro.
Proceed. Okay. There's one small. I'll show you a code, and there's one very small hindrance, not hindrance in the code. One small thing in the code which I want all of you to notice, and I want you to tell me why it is that way. Okay. So again, let me quickly do it. So while left is obviously lesser than right, you find out the middle. Now here is where I want to ask you the question. Why can't I simply do middle equal to left plus right by 2? I mean, that's how you calculate middle, right? You do left plus right by 2. That's what you do with middle. That's how you calculate the middlemost element, middlemost index. Why am I doing L plus R minus L by 2? The one who tells this gets placed in Amazon for sure. Okay, kidding, but yeah. Can someone please tell me why am I doing L plus R minus L by 2 and not just L plus R by 2? Both of them are almost the same. So, can someone tell me, do you have an idea of why we are doing it that way?
Integer overflow.
What? Exactly, integer overflow. In a lot of the CP problems, no, suppose I was doing L plus R by 2, and let's say I'm dealing with higher values of R and L, probably 2 power 31 minus 1. I'm dealing with the most maximum element. That way, if you do 2 power 31 plus another big number by 2, that won't work out, right? Instead, one big number plus R minus L by 2. I'm basically reducing the number. So as to prevent integer overflow, as Sundar said, to prevent integer overflow, I'm doing it as L plus R minus L by 2 instead of just L plus R by 2, right? And as explained in the presentation, everything is the same. If the middle index equal to the particular element, return the index. If it is less than this, concentrate only on the other part of it. That is, if the element is greater than the middle, concentrate on the right part of the index. So you basically move left equal to middle plus 1. It's concentrating only on the right part, so moving the left equal to the middle plus 1. Otherwise, I'm concentrating on the left part, right equal to middle minus 1. So everyone knows this, so I'm not going to go in depth explaining the code. So the element that we are searching here is 10, and it's present at index 3. Is this cool? Can I proceed? Before I proceed, how many first years in this meet? Can the first years all give me a raise of hands? How many second years in the meet? Okay, I see no first year. That's okay, right. That's nice. That's nice. And any third years or someone? Is there any third year? Oh, okay, cool. We have a balanced audience today. So now is where the main meet starts. All this was just like warm up. So we'll start off with the main meet still doesn't start. You surely would have learned all of this in your first year itself. So we'll go on with sorting. Okay. So in sorting, right, we'll first do with O of n square. We'll look at algorithms which do O of n square. Then we'll do algorithms which look at O of n log n. And then we'll look at algorithms which do O of n. Okay. This will be the in for the day. This will be the flow for the day. Obviously, you guys should have studied O of n square. We'll be concentrating more on O of n log n and O of n. Can anyone tell me algorithms which fit in the O of n square? Can the most basic algorithm that you learned in your first year?
Bubble sort.
Obviously, bubble sort. Anything else?
Selection
Bubble
sorters.
sort. Selection sort. Okay. One more. Bubble sort, selection sort, and then
Insertion.
that's all. Bubble, selection. bubble selection sort and insertion sort work on O of n square. Can someone tell me what works? So bubble, insertion, selection. Can someone tell me? Can someone tell me? Can someone tell me what works on O of n log n? You at least find this. You're free to at least okay. I'm getting answers in the heap, merge, quick. Yeah. So we'll be learning about quick sort and merge sort in this. Okay. This is new to all the second years. Insertion selection. I think we learned in our second year. So quick sort and merge sort will be a new concept. And can someone tell me what is O of n? The algorithm will comes in O of n.
Radix.
Okay, radix sort. Very good. Anything else? Anyone else? Some algorithm which comes in O of n. Radix sort is very good. Okay, but that won't be in today's this thing. Anything else that we are learning today? We're learning counting sort. Counting sort is that one particular sort which looks very. I mean, it's very difficult to do O of n square and O of n. Okay, you may think, oh my god, majority of the algorithms are in O of n square. How will I make some algorithm which is in O of n? But then counting sort just does that. It's very simple to understand. But yeah, it's very simple to understand and you'll have fun learning counting sort. I personally had fun while learning about it. So we'll first move on to bubble sort. Again, I'll be rushing here in bubble sort because all of you have already studied. So what is the main idea of bubble sort? The main idea of bubble sort is I'll be comparing two adjacent elements. Two adjacent elements, that is ARR of I and ARR of I plus 1. I'll be comparing them. If this is greater, I will swap them, else I'll keep proceeding. Okay, very simple to understand. So I think I'll just go with an example so that, I mean, even though we mostly have mugged up all the sorting techniques, we often don't trace it, right? So I will just take one small tracing for bubble sort. Let's take the array to be 12, 45, 23, 51, 19, and 8. Let's take this as an array. So what did I say? I will repeatedly swap two elements. I will repeatedly swap two adjacent elements. Okay. First one being 12 and 45. I will actually start from, I'll start checking from 45, right? Okay. Now, obviously, 45 is greater than 12, so no swap. 45 is greater than 12, so no swap. Okay. Then I'll continue. Then in the next iteration, I will check 45 with 23. I will check 45 with 23. Over here, 23 is lesser than 45, so I'll swap them. So right now I'll have 12, 23, 45, and the rest of the array, 51, 19, and then 8. After this, I'll be checking for 45 and 51. Do I need to swap them? No, I don't need to swap them because 51 is larger. So next pass. Next, I'll be comparing 51 and 19. Obviously, 51 is lesser than 19. So what happens is 12, 23, 45, 19, 51, and then 8. After this, I'll be comparing 51 and 8. Again, since 8 is less than 51, I'll swap them again. 12, 23, 45, 19, 8, 51. Can I stop here? Is algorithm over or do we need to do something else? Is this a sorted array, everyone? Is this a sorted array or do I need to do more iterations?
We need another loop.
Not another loop. We need another n minus i minus 1 iterations. That is, you need the size of the array is 1, 2, 3, 4, 5, 6. We need like 5 more iterations. Okay, that's why it's O of n square. Okay, so you have to again do this. 12, 23 is okay. 23, you'll be checking. I mean, right now I'm not writing it down because I want to go to the main thing. We'll be checking 12, 23, 23, 45, and 45, 19. Swap 19, 45, 8, 21. By the way, guys, okay, I'll complete this first. And then 45, 8 again swap. 19, 8, 45, 51. Sorry. 51, and then you keep swapping. And I said you'll be doing 5 more iterations until you reach the end, right? Before that, fun fact, why is the name bubble sort? Why is it called bubble sort? Why not something else? Why is it called bubble sort? Can someone please explain why is it called bubble sort? Why does the name bubble come? Anyone? Okay, it's very cringe, but the reason why bubble sort comes is at every iteration. No, at the end of every iteration, at the end of every iteration, the largest element bubbles up. Largest element comes out or bubbles out. As in we see in the first iteration, 51 was somewhere hidden right over here. But then at the end of the iteration, we surprised see that 51 is in the end. Similarly, so this is one iteration, right? In the next iteration, 45 was somewhere over here. But at the end, it came out, it came out, right? It bubbled out. So similarly, the next iteration, 23 will come up, the next iteration, 19 will come up. So at every iteration, the biggest number comes out. At every iteration, biggest number comes out. Did you get a fair understanding of this? People, did you get a fair understanding? Can I directly jump to the code? Okay, cool. So a detail, as I said, a detailed course on binary search will be there. But okay, one second. Can someone tell me how can I modify bubble sort so as to make it better? How can I modify bubble sort so as to make it better? Anyone out there?
We can give j is equal to I plus 1.
Okay, that is one method. Anything else? Yeah, that's an optimization method. Any other optimization method? We learn this in our second year, boys. Come on. See here, basically, if no more swapping comes apart, that is, after a point, if I don't swap any two elements, I repeat, after a point, if I don't swap any two elements, can I say the array is already sorted? You know this, right? After a point, if I don't swap any two elements, the array is sorted, right? Did you get what I'm trying to say? Did everyone get what I'm trying to say? Okay, yes, okay, I'm sorry, I didn't see the chat. Okay, so that's the small modification that you can do to bubble sort. But that will also, but the time complexity will still remain the same. Since the time complexity will be go with asymptotic analysis, you deal with very big numbers. That really doesn't matter. So yeah, so this was the array that I gave, and it's sorted as 1, 2, 3, 4, 5. Cool. Now we'll jump to the next one, which is insertion sort. So can anyone tell me the main idea behind insertion? Okay, it's not coming in my mouth. Insertion sort. Can you tell me the main idea behind it? Can someone tell me the main idea behind it?
Having the first I elements of the second. At each second.
Can you be a bit louder?
I mean, we will always have the first I elements already sorted, and we'll check we'll try to put the element in the correct position.
Yeah, you're absolutely right. So it's more like you insert an element from the unsorted array to its correct position in the sorted array. I know the English seems too fancy, but I'll once we are through an example, you'll surely understand it. To its correct position in the sorted array. So let me take an example. 12, 45, 23, 51, 19, and then 8. Okay. First, what we assume is that the first guy is already sorted. Like you start the comparison from here. Okay, you'll start the comparison from here. So this will be your pointer. Now you will compare this particular element that you're with everyone in the sorted array. So as Sundar said, as Sundar rightly pointed out, this will be the sorted array. This entire thing will be the unsorted array. Now read the English, it will be much more comprehensible. Insert an element from the unsorted array to its correct position in the sorted array. So I'll take the 45, I'll compare with everyone in the sorted array. So obviously 45 is greater than 12. So I'll insert 12, 45 like this. So this becomes sorted. I'll have the remaining 23, 51, 19, and then 8. What do I do next? Now my pointer is pointing out here. 23. So right now I'll compare 23 with the elements over here. Is 23 less than 45? Obviously. So I will do one more. I'll do one more jump. Is 23 less than 12? No. So you place 23 in between 45 and 12. 12, 23, 45. So now this becomes a sorted array. And then you have 51, 19, and then 8. Now you compare 51 starting from this element. You compare 51 with 45. 51 is greater than 45, right? So director, just put 51 there. 12, 23, 45, 51. And then you'll compare with 19. So again, the thing is, you'll start comparing from the rightmost element to here, okay? So you'll compare with 51. If it's less than 51, you'll again compare the next element. If it's less than 45, again compare with 23. If it's less than 23, again compare. Now it's more than 12. Whenever the particular element that you're searching is more than an element in the sorted array, you insert it. And how do you insert it? You basically push everyone else by one step. You push everyone else. Push. Okay, I don't mean the stack wala push. I mean the normal. You push all the indexes by one. Push everyone by one step. As in right now, 19 will occupy the space of 23. 23 will occupy the space of 45. 45 will occupy the place of 51. And 51 will occupy the place of 19. Did you understand this? I'm doing a swap, and I'm pushing it. Pushing everyone by one index. Is this understood? Then obviously you compare it with 8. Check with 51, no. Check with 45, no. 23, no. 12, no. 8, no. And then last index is, 12, no. And then you put 8 here. 8, 12, 19, 23, 45, 51, 8. Is the intuition behind the algorithm understood? And then we can move on to the code. The intuition understood, people? Okay, cool. So I'll explain every line of code now. Okay, so what I'm doing is, everything is here. Okay, insertion start. I'm taking in an array and taking in the number of elements in the array. Okay. Current equal to ARR of I. This is basically points out to the first element in the unsorted array. Okay. First element in the unsorted array. I'm going to compare this with everyone in the sorted array. Am I right? Well, A and J equal to I minus 1. Obviously, if you see that, if you had seen it pictorially when I was writing it out there, this is the last element of the sorted array. Am I right? Last element of sorted array. So if ARR of J is greater than current, if it is greater than current, and obviously J is less than 0, this is for checking the boundary condition. J is greater than or equal to 0, checking for boundary condition. I push everyone by one index. Am I right? I push everyone by one index. After this, I do J minus minus so that I can compare with the other people. I can compare with other people, and if 0 reaches, that means I reach the end of the sorted array. So I can wrap up the while loop. After this, I told you, right, I'm swapping, not exactly swapping, I'm replacing one of the elements. So that J plus one element will be replaced by current. wherever this condition fails, wherever ARR of J is greater than current fails, that is, if the current is greater than ARR of J, that means I need to insert it right there, right? If the current is greater than that particular element, I need to insert it after that. So it will break away from this loop. At that particular position, I'm placing the current element. Is this understood? Is this understood? I need responses, please. Only then can I continue. Okay, beautiful, beautiful. So I'll run this. So the array that I gave was 5, 3, the same array. I gave him the pointer of the array and I gave him the size of the array, and here is the printed array. Did everyone understand the code for sure? The algorithm is naturally easy to understand, but did everyone understand the code? Okay, cool. So move on to the next one. Now is where the major need starts. The next one being merge sort. Now this is new for I think most of you, since majority of this meet has second years. It's new for all of us, so let's pay a bit more attention to it. The first algorithm that we'll be looking is merge sort. Okay. Merge and quicksort are very similar. They're very similar. So if you understand merge sort, you'll obviously grasp quicksort quickly, literally. Sorry for the bad pun, but you get the idea. So what is the main idea of merge sort? Merge sort works on the principle of divide and conquer. Given an entire array, I break it up and then I sort the. I break it up, I sort, I break it up, I sort, I break it up, I sort. Sorry, actually merge. Break it up, sort, and merge. Okay, that's where the name merge sort comes from. So first I'll tell you an example and then it'll get easier. Let's say I have 6, 3, 9, 5, 2, 8, 7, 1. So the first thing is, so the first step is I need to find the middle pointer. Okay, I need to find where the middle of the array is. So there are 8 elements. Obviously, this is the middle. Correct? So first you divide these people. Right now I have 6, 3, 9, 5. You take these equals separately. 2, 8, 7, 1. Okay. After this, the middle is obviously again here. What does this become? I divide this further. 6 and 3. 9 and 5. Divide this guy also further. 2 and 8. 7 and 1. Okay. Once I have reached this place where I can't, obviously after this I can't divide them, right? They're already in the least breakable state. I've already divided them much more. After this, what I do is, I sort these two. I start sorting them. If I sort them, it's very easy to sort, right? 3 and 6. Here also 5 and 9. Here it's already sorted, so 2 and 8. And here will be 1 and 7. Now the division part is over. Now I need to also conquer. Now that I've divided, now let me conquer it. Now here is where the main hint of the algorithm starts. I will be merging 3, 6 and 5, 9. When I'm merging them, I'll be sorting them also. I'll repeat until this step is the division step. Where I'm dividing them into least, like 6 and 3, I can't divide them further, right? It's the most least divisible system. After this, I start individually merging all of these people. Here is where the merge path starts. 3, 6, 5, 9. If I merge it, if I merge and sort it, I'll have it as 3, 5, 6, 9. In 2 seconds, I'll tell you how I am taking these 4 elements and getting to 3, 5, 6, 9. And then again 2, 8, 7, 1. I'm conquering them. So I have 1, 2, 8, 7. Once done again, I'll conquer these 2 people. I'll merge and sort them. So 1, 2, 3, 5, 6, 7, 8, 9. So basically this is the division part. This is the merging and sorting part. Sorting and merging part, or any which ways. So this division part though is easy. I'm sure all of you can code it. Find out the middle element, make one array like this, make an array like this, again find out the middle element, make an array like this, make an array like this. Can someone tell me the good approach in this? As in, which is the famous tool in the entire of, in computer science, which is used in dividing people? Which works on dividing and then conquering, dividing and conquering? Which particular tool can I use?
Recursion.
Can you come again? Recursion. Yeah. So our favorite recursion comes over here. So we'll be using recursion over here. Okay. So division part, all of you have understood, I'm pretty sure. So let me just concentrate on the merging part. Let me. So in this step, right, I merged 3, 5, 6, 9 and 1, 2, 8, 7. 3, 5, 6, 9, 1, 2, 8, 7. Now here is why we all need to raise our ears and listen to this very carefully. How do I go about merging and sorting them? Let's say I have two pointers, P1, P2. These two are separate arrays, right? Now I'll compare P1 and P2. So 1 is basically less than 3. 1 is less than 3, so I place 1 over here. Now how I remember this algorithm is, the person who is heavy, the person who is larger in number, gets stuck. The other pointer moves on. The other pointer moves on. So 1 is less than 3, so 1 gets to 1, P2 gets to 1. Now P2 points to 2. I'll again compare 2 and 3. See here, P1 still didn't move on. P1 is still stuck with 3. So 2 is still less than 3, so 2 will be there. So again, this pointer gets to move, but this pointer still remains in 3. Now I'll again compare 8 and 3. Now, sorry, I think it's 7 and 8 in the example. I copied it down wrongly. You have 7 and 8. I'll compare 7 with 3 again. Now here is where 7 is greater. Okay, so he's stuck. So the pointer will be stuck over here. And this pointer gets to move on. So I'll have 3 over here. This pointer gets to 1. Now P1 points to 5. Now I'll compare 5 and 7 again. So 5 is a winner. And again, this pointer gets to move on. That pointer is still stuck. I'll compare 6 and 7. 6 gets to stay. 6 moves on and 7 still gets to stay. I'm comparing with 9. Now again 9 and 7. Finally 7 gets to move. 7 will, the pointer will point here. 9 is still stuck here. And then I'll be comparing 8 and 9 right now. 8 and then the remaining element is 9. So please remember the fact that there's one element remaining and then I'm doing it like this. See here, until this step all of you understood, right? I'm moving 2 pointers and I'm checking. And then whichever element is left off, I'm blindly putting them here. That much is understood, right? Is it understood, people? Do you understand? This is the main concept of merge sort. You take these 2 pointers, you iteratively move them, you do comparisons, and then you put them in. Did everyone understand this step, or do we go with one more example? I need replies from you so that I can proceed. Hello? Shweta, am I audible? Okay.
Yes.
Okay. So, since all of you understood it, I'll directly jump to the code. Code is also a bit tricky to understand in the first go, but we can surely grasp it. Okay, sorry guys. Before this, let me. I have a small fun derivation of how it is O of n log n. Okay, so I will just do one small derivation. So for all those people who are kind of interested in maths, it will surely interest you. So here we have a recurrence relation, right? Here we have a recurrence relation. Recursion, right? So you have a recurrence relation. So what is basically happening is, I am first breaking them into 2. Here is where the division comes apart. Here is where I am dividing, and then I am conquering. Why it is T of n and why it is n, you will get to know sometime once I show you the code. But this is more like on the extra part. So if you understand, well and good. Otherwise, no need to worry. I'll show you the code. You'll understand. So here is the division part. Here is the merging part. Okay, that's why n is coming. Now if it's t of n by 2, I'll have t of n by 4 plus t of n by 4 plus n by 2. Is everyone getting a grasp of this, or am I rushing too fast? Then next I will have t of n by 4. This will become t of n by 8 plus t of n by 8 plus n by 4. Okay. This will go until t of 1, which is equal to 1. Okay. Now, does this remind you of something in 11th and 12th? We would have surely done this in AP and GP, and this series is called as something. Can someone tell me the name? There's a beautiful name for this. Does anyone remember the name? You have surely heard of telescopic series, right? So this usually comes in the APGP chapter, where the main fund of this is I have to cancel out some. I have to cancel the term somehow. Right? I have to somehow reduce this entire expression. Yeah, but the problem here is I can't cancel it because here I have an n by 2. Sorry, yeah. Here I have an. Okay, so if I have to simplify and write this down, I will have. I'll just add this. I'll add these up. T of n equal to 2tn by 2 plus n. The same thing. I'm just adding these two up. Nothing big. T of n by 2 is 2tn by 4 plus n by 2. And t of n by 4 is 2tn by 8 plus n by 4. Now see here, it's I can't cancel these two people. Right? Even if I cancel one, t of n by 2 will be remaining. So can someone tell me the mathematical adjustment that I need to do over here so that I can cancel those two terms? I'll multiply this entire guy by 2. I'll multiply this entire guy by 4. The next person by 8. And now you'll know why. If I multiply this entire person by 2, what happens with this person? I will have a 2tn by 2. Here I'll have a 4tn by 4. And then this will become n. This will become n. Here I'll have an 4tn by 4. Here I'll have an 8tn by 8. Here I'll have an 8tn by 8. So, dup. This keeps going on. Right? Did you understand this beautiful recurrence relation? I'm basically trying to cancel. That's why I'm doing the into 2, into 4, into 8. So what will be remaining? Is n into 1 plus n by 2 into 2 plus n by 4 into 4, so on, right? And how many terms will I have? So basically n plus n plus n plus n. How many terms will I have, people? How many terms will I have? Someone? How many terms of n will I have? I'll have log n terms, right? No, I'll have log n terms. N amount of log n terms. Why log n terms? Every time I'm dividing the array by 2, right? I have, let's say first time the array is 20, then it's 10, then it's 5, then it's 2, and then it's 1. So which series follows 1 by 2 plus 1 by 4 plus 1 by 8? It's like any series where you're cutting down by half. No, it's usually the log n series. Okay, so I'll have log n terms. That is why, ladies and gentlemen, it is n log n is the time complexity. I'm sorry to have brought the math, but for people who found it interesting, give me a S in the chat or give me a raise of hands. It'll be fun. So let me jump onto the code. I'm glad you liked it, Kirtana. So I'll share. This is the merge sort. So again, the main idea here is I divide the array, sort the left part, sort the right part, merge it. Okay. So now the code is a bit lucrative to understand in the first go, so I'll slowly explain it. So this is the merge sort function. What am I doing first? I'm finding out the middle part. I'm finding out the middle part. Then I'm calling the merge sort function again for the first half, merge sort again for the second half. Then I'm merging the two halves. Okay, break. This is divide. divide again, and here is where I'll be merge sorting it. Okay, so this function is pretty intuitive to understand given the example that we have covered right now. Okay, now this merge function is the main function. Okay, so what I'm first doing is I'm finding out the size of the leftmost array. I'm passing the left index, the middle index, and the right index. I'm finding out the size of left array. Similarly, this is the size of the right array. Okay. Then I'm having two temporary arrays. I'm creating two temporary arrays. I'm copying down, I'm copying the right array, copying the left array. Okay, until this is crystal clear, I assume until this is crystal clear. Now, after this is where the main thing starts. So I have 2 pointers, right? I have I and j. I have I and j, and this k pointer is for the final array. Is for the final array, okay? And this k pointer will start with L. It's often you may often mistake L to be 0, right? But think of it in the recurrence point of view. I know it's very tempting to put in k equal to 0 and proceed with it. Only during the first step is k equal to 0. After this, whatever is the index of the L pointer will be the value of k. Right? The recurrence relation. K, I mean the L pointer is basically the leftmost pointer, right? That's why int k equal to L. Okay. So going back, I'm comparing the two. See here, obviously, J is a heavier guy, right? If this condition goes about, J is a heavier guy. So I only increment the I pointer, I keep the J pointer like that. I'm not incrementing the J pointer. So I put that in the final array. I don't increment the J pointer, I only increment the I pointer. With the other ways, I increment the J pointer. Is that understood? I told you, right, the heaviest person gets stuck. That's basically this while loop condition. Okay. If you realize, people, I have an AND condition over here. Even if one of them fails, it will come off. If you remember in our example, the last element was, we actually didn't compare the last element. As in, the last element, we didn't have anyone to compare it with. So we at the last, we put that into the array, right? So that's what we are doing. If it's for every other element, for the remaining elements, just put them in the sorted array. Okay? I know it's very difficult for all of us to grasp this code in 5 minutes, but if you understood the idea, and if you sit and look at this code, you'll understand it. Okay, we'll be sharing the resources too, so that's not an issue. So again, the array is 5, 4, 3, 2, 1. I'm passing the left index, I'm passing the right index, and I'm passing the array. Okay, can you move on to the next one?
Can you tell what's the use of the variable k?
Okay, so the variable k is to put it in the sorted array.
The
okay,
final output array.
Yeah, the final output array.
Fine.
The sorted array. K represents the index of the sorted array.
Cool.
Okay, can I move on to the next one?
Yeah.
After this, everything becomes very simple. So the next one is quick sort. Okay. Quick sort and merge sort, honestly, for me, when I was learning it, they almost seem the same, and they are basically the same. Both of them are O of n log n, and both of them work on the same principle. Here you just have a fancy English word quick sort. Okay, that is basically, it's called pivot. I'll explain it, but then it's nothing. It's very simple. I'll give you an example. This also works on the divide and conquer. Same thing as merge sort. 6, 3, 9, 5, 2, 8, 7. Here I'm going to introduce a very small concept called as pivot element. Okay, this is up to you. I can choose pivot element to be the last element, or I can choose pivot to be the first element. That is basically right element or left element or middle element. I can choose anything to be my pivot. Okay, so over here I'm just going to choose my pivot to be the last element. So this is the pivot. Okay, what happens in the first iteration is I put 7 in between. People less than 7, more than 7. Okay, as in the first, I will explain the code later. So 7 is there. So who are the people less than 7? I have 6, 3, 5, 2. No, sorting won't happen here. Sorting will happen only when I divide them into the most elemental states. Here I'll have 8 and 9. Again, for this particular array, what is the pivot element? The pivot element is last element, right? I consider it to be the last element in this case. So again, put the pivot element in the middle. There's no one less than 2. There's no one less than 2, but who is greater than 2? You have 6, 3, and 5. You leave this pivot element to be as it is. Again, 8 and 9. The pivot element is 9. There's no one greater than 9. There's only 8 less than the pivot element. Now I can't break these people further, so I will let them be. But then I can work on this, right? I can surely work on this. So again, 5 is my pivot element. So this will remain as it is. All will remain as it is. 5 will be there. 6 will be here. Who is lesser than 5? 3 will be here. Okay. Once you're done with this, you'll automatically notice that the entire array is sorted. Check it out. You have 2, 3, 5, 6, 8, 9. I mean, 7 is also there, right? 7 was in the middle. Is the main idea understood? I will explain the code slowly on how we are getting the smallest, how we are getting people less than 7, people greater than 7 and all of that. But did everyone get the main idea of this? They have some S's in the chat, yes, no in the chat. Okay, cool. Now in this entire thing, no, there's only one function which you need to learn. Again, over here also we'll be using recursion. So there's something called as a partition function. This partition function is what helps us get the middle element. I mean, it's not the middle element, the pivot element, and finding people less than pivot, finding people more than pivot. So how I do that is, so we understood what we are doing. Now we'll do how we are doing. So again, same example, 6, 3, 9, 5, 2, 8, 7. This is my pivot element. Now listen to me carefully. I have an I element which points. Okay, so I element basically points to one thing less than j. You will notice at the end of the iteration, at the end, I will point to the last element lesser than pivot. Last element lesser than pivot. This is at the end of the iteration. Okay. Until then, we'll keep I as it is. So what happens in the partition function is that I will, first of all, I will compare with pivot element. Okay. I think I'll just put the code here so that I can explain along with the code. One second. I need to copy based on what getting this one. It's not getting pasted for some weird reason, but okay. First, I will say pivot. Okay, first I'll explain what I'm doing. Your pivot will be the last element, correct? Pivot equal to ARR of rightmost element. First statement is understood. Pivot is this. After this, I will say I equal to L minus 1. Int I equal to L minus 1. Okay. Then I will say for int j equal to L, for j equal to L, and L is less than R, obviously. Leftmost element, the leftmost index is less than the rightmost index, j plus plus. Here's our main condition comes. If the pivot is greater than ARR of j, if pivot is greater than ARR of j, increment I, swap I and j. Increment I, swap the elements of I and j. Swap ARR of I, ARR of j. Okay. And once you're done with this loop, here, when I was doing this, even I didn't get the intuition first time. Like, you may be thinking, okay, he's just telling the code, but how do you get the code? So it is a bit difficult, but if you look at it, you'll understand. And then at the end, I will swap the ARR of I plus 1 and then R, ARR of R. I've written Greek and Latin here, so sorry for that, but I'll explain now. I'll make the Greek and Latin into English. Okay. So what I say, your I will be pointing to L minus 1. L is this, so I'll be pointing to L minus 1. Okay. Now first I will check if 6 is I will first check 6 and 7. Pivot and ARR of J. I'll first check 6 and 7. Now we notice that 6 is less than 7. If it's less than 7, just increment I. Just increment, increment I and swap ARR of I and J. As in, right now the array becomes 6, 3, 9, 5, 2, 8, 7. I've incremented I, and J is already here, and I'm swapping I and J, right? But here, I and J are the same element, so there's no swap happening. Next, I'll compare with 3. Again, 3 is less than this thing, so J is obviously pointing to 3. So increment I, and the same, pointing to the same element, so no point in swapping. Okay. After this, you're obviously incrementing J in every step. Here is where it is. Now we see that this particular 9 is greater than 7. So this entire inside condition won't get executed. Only J++ will happen. So I is still stuck over here. I is still stuck over here, and J is here. Okay. So I will just increment J. So I'll have 6, 3, 9, 5, 2, 8, 7. I is still stuck over here, but J has moved on to 5. Okay, this is J. Now I'll check J with 7. Now it is less than 7, so I will do I++ and then I will swap them. 5 is less than 7, so I'll do I++ and then I'll swap these two people. So right now, the I++ points to here. This is I++. Now the I++ is done. Swap these two people. So right now I'll have 6, 3, 5, 9, 2, 8, 7. The I is pointing to here. The J is pointing to here. And then the next iteration, I'll be pointing J to 2. Right. Again, 2 is less than 7. 2 is less than 7. So what do? I increment I. So right now I points here. I swap I and J. So I have 6, 3, 5, 2, 9, 8, 7. Okay. Then I again increment J. So I is still, one second. I is over here, right? Yeah. I is over here. I increment J. J points to this element. What happens? J, okay, at this condition, no? J is at the end condition. That is, L is less than R. J is less than R. So over here, the loop actually kind of stops, right? Now what do I do? Now here's why you need to remember. After this, the J stops. This last line gets executed. Swap of ARR of I+1, pivot element, right? What is I+1? I+1 is 9, right? Swap this as the pivot element. Swap these two. So what happens? 6, 3, 5, 2, 7, 8, 9. This, ladies and gentlemen, is the partition function. I remember telling you what the I will point to at the end. I said at the end I will point to the last number less than pivot. I will point to the last number less than pivot. What is the last number less than pivot? 2. Correct? So I at the end of the day is pointing to 2, right? So that everyone understand this. I know there was a lot to catch up in this, but did everyone get the concept? Can I have yes, no, or do I repeat with another example? Can I get responses, please? Which part, Vishwa? Which part would you want me to repeat? Okay, cool. Since I'll repeat it again. Here, I will have 2 pointers, okay? I'll have pointer I, I'll have pointer J. And then I have the pivot pointer. This much you all of you have understood. What I will do is, I will keep incrementing the J pointer. J is in loop, okay? I'll keep incrementing the J pointer. If the j is less than pivot. If whatever array ARR of j, if ARR of j is less than pivot, I will do I plus plus, I will swap them. Once I do I plus plus, I will swap ARR of I and ARR of j. That is what is happening. Once I show you the code, you'll probably understand better. So this partition function essentially also tells us at which part am I placing the 7. What is the index of the last element after sorting? So I'll repeat it again. Pivot points to the last element. This one, am I presenting my screen? So can someone unmute their mic? I want someone to unmute their mic. I will explain line by line. Just tell me yes, 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 or no, no, no. Okay. Can someone volunteer and Vishwa, and can you switch on your mic for a second?
Yeah, fine.
Yeah. So here I'll be explaining every line. Tell if this line is okay or not. Okay. Pivot points to the last element. This much you understood? Pivot points to the rightmost element. Correct?
Yeah, fine. Yeah.
Okay. I points to L minus 1. 1 before the left element. The I pointer points to one element before the left element. Okay?
Okay.
Okay. Next. I am looping J. I am looping J. Looping J until the rightmost element. This much you understood? Looping J until
Yes.
rightmost element.
Yeah, I understood.
Now concentrate on this. If that element, if ARR of J is less than pivot, if ARR of J is less than pivot, you remember the I over here, right? I am incrementing the I. If ARR of J is less than pivot, I am incrementing the I.
Okay.
After that, I am swapping ARR of I and ARR of J. Okay? I repeat again.
Yeah.
I am looping J till
Understood,
the end of the loop. With less than pivot, I'm doing I plus plus. I'm swapping ARR of I and ARR of J. If it's not greater, then obviously only J plus plus will be done, right? Only J plus plus will be done. If it's not greater, this condition fails. We'll again go back to the for loop. Only J plus plus will happen. Correct?
Yeah.
Okay. Once I'm done with it, once I've reached the end of the array, remember in the example how I was swapping 9 and 7 at the end. 7 was still in the end, and 9 was the last pointer. So I was swapping I plus 1 and 9. What is I again? I told you I points to the right over here. I points to the one before left. Also points to the last element less than pivot at the end of the iteration. Okay. Last element next to the pivot, and I plus 1 will point to the then you're swapping I plus 1 and the pivot element to get the pivot in between. Once I've done that, I'm returning the pivot location. Okay? Which part should I explain again? Parani, Shravya, we understood?
If you could take another example like
Yeah, it's clear.
previous one,
If I could take another example like, okay.
like the previous one.
Okay.
Not in here, like the Microsoft.
Yeah, in the whiteboard, yeah. Okay. Just copying the code, so. For weird reason it's not getting pasted, but let me take a very small example. Let's take 5, 6, 5, 4, 8. Okay, let's take 6, 5, 4, 8. Cool. So again, where does pivot point to? Pivot points to this. Correct? Pivot points to this. Pivot points to this. I points to one thing before L. This is L, right? This is L. This is R, and this is also pivot. Correct? I points to one person before left. I equal to L minus 1, right? Int I equal to L minus 1. Points to one guy before this thing. And J points here. I'm going to loop J throughout till it reaches R. Okay. So first let me increment J. So first I'm checking ARR of J and the pivot element. Is it greater or lesser? The pivot element is greater. So what happens? I plus plus happens. I was pointing here. Right now, where will I point? I will point here back to the 6. So I is also pointing here. J was also pointing here. I have 5, 4, 8. The next iteration, what am I doing? I am putting J over here. Correct? J plus is obviously loop is that J plus plus. Now what happens is this particular again 5 is less than 8. Same condition as 6. What do? I increment I and I swap it. Even in the previous step when I incremented I was pointing here, J was pointing here, and since they were the same element, swapping 6 didn't make sense. Like they're the same element, right? So swapping the same element is like doesn't matter, right? The next iteration also 5 is less than 8, so I'm incrementing I was pointing here. Now I plus points here. I will swap these two. Again, they point to the same element, so chill, nothing happens. Again, I have 6, 5, 4, 8. What happens? The I is pointing here. J plus plus happens over here, right? J plus plus happens here. I is here and J happens over here. Again over here, J is less than 8. So J AR or J is less than 8. So again I plus plus points over here. Swapping the same element doesn't make sense. Correct? After this, we have reached the end of the loop. What do we do after this? We swap ARR of I plus 1 and the pivot element. Correct? We basically swap 6, 5. I plus plus points here, right? I plus plus points the element over here. 6, 5, 8, and 4. Now, can someone tell me why this example is wrong? Can someone tell me why this example is wrong? It is already in the sorted thing, right? As in, okay, I took a wrong example because here, 8 is, these elements are already less than 8. These elements are already less than 8. So, I was pointing here, right? I plus was pointing here, now do I plus 1. And then I swap pivot and 8, so it stays in the same location. In the example that I took, every element was less than 8. Should I take another example? Or is this understood?
This is only for the first iteration, right? After that, it will be swapped with the one which is less than the pivot.
No, Vishwa, this is a part of the recursion in the quicksort. This is a part of the recursion in the quicksort.
Okay, fine.
Okay. Oh, the example. Okay. My bad. I took a wrong example because the elements less than 8 are already there, and this like what is the main thing of partition? I will place the pivot element such that elements less than 8, less than pivot, more than pivot. In the example that I took over here, everyone is already less than pivot. Okay. Still the algorithm worked, right? Still the algorithm gave the same result. Right? So can I move on?
We could choose a element like we could choose some other element which is the pivot, right? Instead of choosing the last element.
Okay, good. Yeah. You can choose anything as pivot. You can either choose the first element as pivot or the middle element as pivot. You can use any element as a pivot. I initially mentioned that. You can use any element as a pivot. It can be your first or your last or the middle one also. For the sake of simplicity over here, I just chose the pivot to be the last element. Okay? Can I move on to the next one?
Fine. Yeah, fine.
The next algorithm being counting sort. This is the last one, O of n. This is one of my personal favorites. So, one second. So, how does counting sort work? I'll explain to an example. Please listen to an example and please stop me whenever you don't understand. So I don't have to take another example and kind of understand and kind of explain it again. So let me take an array 1, 3, 2, 3, 4, 1, 6, 4, 3. This is the array that I need to sort, and this raising element is in O of n. So please play at your utmost concentration to this. This is the finale of this particular. This is the last topic that I'm going to teach. So first I take the maximum element. What is the maximum element? Can someone tell me what the maximum element is? What is the maximum element here?
6.
6. So the maximum element here is 6. So first I will create an element. Sorry, I will create an array of 6 spaces. Zero, 1, 2, 3, 4, 5, 6. First step is creating this array such that the size is actually max element plus 1. Max element is 6 and there are 7 spaces in this array. Am I right? We have to also include 0. Okay. Next one is counting the occurrences of the element. That's where the name counting sort comes from. How many times does 0 come in? How many times does 0 come in this given array to sort? How many times does 0 come in the given array to sort? 0. Beautiful. Okay. How many times does 1 come? Someone unmute their mic too. I have to do alt tab, keep coming to the meet and scene. Can someone unmute it and me? How many times does 2 come?
1 time.
3?
3 times.
4?
2 times.
5?
None.
6?
Once.
Okay. First two steps are clear. Next step is add the previous elements, add count of, just add the previous elements, as in do a summation. What I mean by that is the same array, okay, same array. 0, 1, 2, 3, 4, 5, 6. Same element, same array, 0. What is 0 plus 2? I know I'm asking kindergarten questions, but I just want you to keep you guys in the loop so that we are not lost anywhere and like the last algorithm. So what is 0 plus 2? Someone unmute and tell me.
2.
Now, what is 2 plus 1? I'm doing summation. What is 2 plus 1?
3.
3 plus 3.
6.
3 plus this 3. 6. 6 plus 2.
8. 8.
After this?
8.
Here is where the catch comes. If it's 0, leave it like 0. If it's 0, leave it like 0. Okay. And then the last one? 8 plus 1?
9.
Okay. Right now, I've just added all the previous elements except for the 0 part. Correct? Next one. What is the size of the initial array? 1, 2, 3, 4, 5, 6, 7, 8. Initial array is 8, right? Okay. Now, please pay very close attention. I'm just going to write down all these people separately. 0, 2, 3, 6, 8, 0, 9. Okay. This 0 represents 0. This represents 1. This represents 2, 3, 4, 5, 6. Correct? Now, very, very simple. Take the leftmost person. Take the leftmost person, that is 3. What is the count of 3? Again, I want someone to unmute. This is where there's possibility of us getting lost again. So can someone please unmute and tell me what is the count of 3? People, please, one of you unmute. டேய் அன்மியூட் பண்ணுங்கடா. Hello.
What is
3,
actually
3.
8 here?
3 is the element over here. This element. I'm going
No,
back
I'm
to the first
actually
array.
asking the size. Like, you have created an array, right, of size 8.
Yeah.
What is it actually?
It is this array. I'm just gonna sort them.
Oh, I think it's 9 actually.
Oh, okay, sorry, my bad. Okay, cool. Okay, right. Now, so what is the count of 3? What is the count of 3? Someone please unmute and tell me.
3.
No. In this array. What is the count of 3 in this array?
6.
6, right? So what I'm supposed to do right now is do count minus minus. First step is do count minus minus, and then put that particular element in ARR of count, in the position of count. After doing count minus minus, I'll explain. So it is 6, right? The count is 6, right? First do count minus minus. What is count minus minus? Fast, so that we can be in the. What is count minus minus? 6 minus minus.
6 only.
5.
Okay, sorry. Yeah, 6 minus minus. Set me. 4 6 prefix, but you get the idea. It's 5. Okay. So place 3 in the fifth index. Okay. Cool. Place 3 in the fifth index. Very good. Next, take 4. What is the count of 4? What is the count of 4?
8.
Do count minus minus. 7. Put it in the 7th place. Next, 6. Where do I put 6? What is the count of 6?
9.
9. So 8, right? Do count minus minus. Put it in the 8th position. Next is 1. What is the count of 1? Count minus minus 1. To put it in 1. Next one, I want you people to tell me. Where do I put 4? Where do I put 4? What is the count of 4 right now?
At the 7th place.
No. 4 is in the 7th place. Do minus minus first. First do count minus minus. 6, right? Right now the count is 7. Do minus minus. The count is 6, right?
Count is
Oh,
actually
yeah,
8.
okay.
No. From 8 we already got 7. We already
Okay,
placed
okay.
1 4, right? Again count minus minus. Cool? Shankar, did you understand?
Yeah, understand.
So now place it in the 6th position. Okay, after this we have 3. Where do I place 3?
At 4th position.
1.
Very good. Place 3 in the 4th position. Where do I place 2? Where do I place 2?
0.
0th position.
Very good. Where do I? No, one second. Have you all? No, this is the first time 2 is coming, right? No, guys, we'll place 2 in the 2nd position, right? Why 2 in the 0 position? The count of 2 is 3. Okay, minus minus. 2nd position. Why do you guys get wrong here? Did you understand? Are we lost? Should I explain again? Should I explain the 2 part again?
Yeah, 2 part alone.
Okay, see here. What is the count of 2 over here?
3.
3. What is 3 minus minus?
Yeah. The 3 minus minus is 2 now.
So put it in 2. That's all. Now next is 3. What is the count of 3? What is the count of 3, someone? Please.
And with
tell me the
3.
count of 3. So 4. So 3. Put it in 3. 1. What is the count of 1?
0.
So 1 minus minus. So 0. Put it in 1. Do we have the sorted array? Do we have the sorted array?
Yeah, yes. Because this is
That's all. Did everyone understand this? Now we'll just code it. Did anyone understand this? Did you guys get lost somewhere, or were you with me the entire time? Umashankar, Sundar, Bharani, Saloni.
Yeah, understood.
Yeah, understood.
Okay, cool. Now the code is also very simple. Okay, while I'm taking out the code, can someone tell me what is the what is the limitation of this particular algorithm? Not only what is the limitation of this particular algorithm? What is the first step that you did?
Very large
Guys?
number.
See, the first step is we created an array, right? We created that count array, right? We counted every element. Let's say one of the number is 127. You have to create an array of 127, and most of the people in the array will be zeros. You can only do it for small numbers, right? There is space issue over here. So again, I'll explain the code line by line. So code is actually very self-understandable only. So here is the console. I am passing the array and I am passing the number of elements in the array. Okay. So first k equal to 0. First, this particular for loop, no, it is only for calculating the maximum element. This entire 7 lines of code is only for calculating the maximum element. And why am I calculating? So that I can create an array like that, right? What is the first step? Creating an array of the maximum element ka size. So I've created an array of maximum element ka size. Okay, move on. Next, what am I doing? For the entire array, that particular position, as in, let's say the element is 1. If the element is 1, or let's say the element is 2. If the element is 2, count of 2 plus plus. Did you understand this? If the element is 3, count of 3 plus plus. That particular box in the count array, I'm incrementing by 1. Am I right? Yes or no, please, so that we don't get lost. Umashankar, Saloni, Yashashwini, Varani. Which part didn't you get, Shravya? If you could be vocal about which part. Okay, this count. Okay, see here. What is the first step? I'm trying to see how many times each element is there in the array. Correct? I'm trying to see how many times each element is there in the array. Over here, if the element 2 is there, in the box of 2, I should do plus plus, right? So count of 2 plus plus. Similarly, if let's say the element is 3. Let's say ARR of 5 is 3. If the element is, or let's say the element is 4. In the fourth element of the count array, fourth index of the count array, fourth index of the count array, I am incrementing the count. This is understood? Did you understand? Okay, cool. After this, what is this one? This is that adding out the previous elements. Adding out the previous elements. Correct? That cumulative sum that we did. Right? Actually, the 0 part doesn't matter. If one of them has 0, anyway they're not in the main array. So whether I'm increasing their count or decreasing their count, that doesn't matter because they remain not there in the main array, right? So the 0 part actually doesn't matter. So I'm just adding out the previous elements. I'm doing a cumulative sum. Cumulative sum of the count array. Did everyone understand this? Can I move on? Yes or no? Okay, cool. Now see here. Now I have output. Now this is the output array, and the size is the initial array ka size. Correct? Output array ka size is initial array size. Now, from the last element I'm iterating. From the last element I'm iterating till the first of the loop I minus minus. Look at this. Output of first is count minus minus, right? What is the first step? You decrement the count. Decrement the count of whom? ARR of I. Right? And then in that position, you put the sorted one. The single step, but you understand, this is essentially saying first do count minus minus, Once you're done with count minus minus, tell me in the output, tell me the count of ARR of 5. Tell me the count of 3. Tell me the count of 4. How much is the count over there? Okay. And in that position, you place the ARR of 5. This is understood. This is basically count of ARR of 5. Here you're playing with the count array itself. Everything we are handling the count array. Is this understood? Beautiful.
Yes, understood.
After this, after just display. I mean, after this, I'm copying out the contents of the initial array. I mean, you can just display the counter. You can just display the output array, but for formality's sake, I'm copying back to the main array. This actually is not necessary. It's just the output array. I can directly print out the output array. Okay. Validating this up. Good. The same example, and this works in O of n. If you actually calculate the time complexity correctly, this is one loop, so O of n. This is another loop, so O of n. This is another loop, so it's actually O of k, and what is k? K, this is the maximum element. So remember this O of n. I'll try to it's n plus max element plus another n, and then you print it. Okay, so this basically, if you look at it, it is 3n as the maximum element in the array. And since you're dealing with asymptotic analysis, what are asymptotic analysis? We're dealing with very large numbers. N is extremely large. Okay, so whether it's 1n, 2n, or 3n, that doesn't matter to us. It is in the range of O to n, O of n. That is the principle of, that's how time complexity is derived, right? Like if you have such a large number, let's say you have 10,000 and then you add 1, and let's say the maximum element is 100 in it, O of 10,000, 100 is same as O of 10,000. It is the degree that matters. So that's why the time complexity of this is O of n. It is understood. And one of the biggest limitations of this is the maximum, the array can't be too big. It's only for limited positive integers. If one of the element is 10,000, we are doomed. Okay. So did everyone understand? So as homework, this is your problem. This is your simple problem. Considering all the complex stuff that we have done, the problem that I've posted in the chat box is basically nothing. I'm pretty sure you can do it. I'll be sharing the answer to the problem and all the notes that I've taken. So yes, guys. Does anyone have any doubt? We are actually way past time. It's supposed to be finished in 1 hour, but let's just say we got lost in the sorting part, lost in the beauty of the sorting part. So yeah. Can we conclude, Shishan, or no? Shweta, Shishan,
I guess we can conclude now. But guys, before we move out, so I'll give you an important announcement. So as CAA 2 is starting from this week for many batches, like for the second year batch and the third year batch, and it varies from department to department. We won't be having one session from the coming Sunday, which is on 7th, I believe, right? So November 7th, yeah. So we won't be having one session on November 7th. So the next session will be on the next Sunday, which is November 14th, I think. Yeah, it's November 14th. So we are skipping 1 week because of CAAs. You guys prepare for the CAA. In the meantime, you guys can play around with all the searching and sorting algorithms that you learned today. And the next session is also a very important session because it deals with the basic maths that is needed for CP. It includes various small and big mathematical concepts that you need for CP. Right. So if you have any doubt, you can ask it here now, or you can feel free to ask it in the Discord server. Right. So any further queries?
Also, there is something I would like to add upon. Actually, I have got some few questions from people who are attending this session asking that if we attend your sessions, will we be able to master CP? No, that is not right. Actually, we have intentionally named our series as Road to CP and not Master CP. That is because in a span of 2 hours, we cannot teach everything. We are just giving you the important stuff, and then we are providing resources for you to learn. So you should be doing the homework, and a lot of practice is required, and only then you will be able to reach some high level in CP. That is what I would like to tell you all. So the first 3 weeks, I hope you enjoyed these sessions. Here we were seeing some basic concepts, like first we saw about loopings and functions. Then we have seen sorting, searching algorithms, basic searching algorithms. So from next week onwards, we will be taking a little higher step. So next week, as Reason said, we will not be having a session this week, as we are having CAAs, both the second years and third years. So we do not want to disturb you all. So hopefully we will be having the next session on 14th of November. And there we will be covering how to analyze time complexity, space complexity, and the basic maths required for competitive programming, like number theory concepts, bit manipulation, how to calculate GCD, LCM, and those stuff. So please do turn up, guys. Please look out for our posters in the WhatsApp and Discord community. And hope you are doing well with our sessions. Thank you so much. Have a good day.
Yeah, finally, I like to say that many people have been asking us for the recorded sessions as we are recording all the meet. We are planning to release that soon enough, right? So we are having some issues based on the releasing how, when, and how to release all those recorded sessions. Even this session is recorded, but we'll release it soon enough. Okay, so you guys can go back and check all the recordings so that if you have any doubts, you can watch that video, rewatch the video. But we usually encourage you to ask in the server. It's because you can learn a lot, not just by watching these videos, right? So it goes for any YouTube video also. Even if you watch a YouTube tutorial, you won't learn much, right? So you'll only learn when you talk with someone who's having a beforehand experience or personal experience on that issue. And apart from that, if you it's a casual conversation, you can learn a lot from a casual conversation instead of just watching a tutorial video, right? So we usually encourage you to come and talk in our Discord server. We've also seen many people asking about how do you set up for the CPs, because most of the people couldn't set up have a setup for the CP so that they can write code in it. We have also provided some basic information on how to do that. So if you guys have any doubt on that regard, so you can also ask that in the Discord server. It's pretty friendly. Like I've seen most people do not come and ask in the server because they may be shy, but we are reinforcing this point again and again. It's because it's a convenient platform for us to communicate, right? So please don't DM us regarding the recordings or any doubts. We also have a set of team who's always taking a look on the server. So if you have any doubts, you can post on the server. Okay, we'll immediately take a look at it if you're not busy. So thank you for attending the session today. If you guys have any doubt, we'll wait for 1 more minute and then we'll end the session.
Our Discord server of the community is not the place where we just post updates. It is like a community or forum where you guys can interact with each other, because we have a lot of like-minded programmers, competitive programmers.